This is higher, straight line, and we're looking at the collinearity topic. Right, so for collinearity, what we're looking for is that all points, or 3 points usually that are given, they must be in a straight line. So what we're really looking for is something of this order here at the end. What we're looking for is the gradient between two of the points, say that's gradient 1 and gradient 2, they're going to be the exact same. So gradient 1 must equal gradient 2. So that's what I'm looking for. So for here we've got collinearity existing here because gradients are the same, and if I choose the points I'll have a common point between them. So this will be collinear. Over here if I look at gradient 1 and I look at gradient 2, well they're not equal. They're not equal, so that's not collinear, okay, because the gradients are not parallel. Okay. If I look at this point here, I can see that I've got gradient 1 and gradient 2 look the same, and they actually are the same, so the gradients are the same, but there's no common point, okay? So no common point. So here we don't have collinearity either. So this one here is collinear. They're parallel, gradients are parallel. And what I've got is a common point. And that's really what I'm looking at as I go through and try and prove that points are collinear. Right, let's do the first example here, and I'll give you 3 questions to do after this. Right, prove the points P, Q and R are collinear, so they are in a straight line. Let's go for this one first of all. So what I'm going to do is I'm going to work out the gradient of P to Q. Right, so gradient PQ, and that's going to be working on y2 minus y1 all over x2 minus x1. Okay, so let's go for the minus 3. Take away minus 5, all divided by 0, and we'll take away minus 6. Gathering that together, what I should have is 2 all over 6, and which gives me a gradient of a third. Next, what I'm going to do is I'm going to pick another pair of points. I could choose P and R, or I could choose Q and R. Let's just go for Q and R this time. What I'm expecting when I get this, if they are collinear, that the gradients are going to be the same. So y2 minus y1 all over x2 minus x1, just the gradient formula. We're going to start with this point here, so it's 1 take away minus 3, and I've got 12 take away 0, giving me 4 over 12, simplified down, a third. So what I can see is that both the gradients are the same. So the gradient of PQ is equal to the gradient of QR. They're both a third. Okay. What I'll say from that then is that the line PQ and QR, they are parallel with a common point used. And the common point that I used was, if I look at it, PQ and QR is the common point Q. Common point Q used. So therefore, I can then state that P, Q and R are collinear. And that's how we're proving that they're collinear. So what I've done here in the working, I've worked out the gradient of one of the lines, the gradient of the other, so that's between 2 points, okay, for each. Gradients are the same. I've stated that they're parallel, a common point used, and therefore they're collinear. So that's very important when we're doing collinearity work for the proof of it. So all of that must be done, especially the statement at the end. Right, so just kind of moving on a touch from that, what I've got here is I've got 3 questions for you and asking, are these points collinear? So what I'd like you to do is to work out the gradients of between 2 of the points, 2 pairs of points, and then to check if the gradients are the same. They'll then be parallel. If there's a common point used, they'll be collinear. If not, they're not collinear, and you'd have to state that as well. Right, so what I'd also like to move on to in collinearity is to try and find out some missing coordinates. So I've got a couple of questions here, and I'll do an example of one, and I'll give you 2 questions to do after that as well. So first question that we're going to look at is find the value of k when the points given are collinear. Okay, so I know that these are collinear, so they'll lie on a straight line. So the gradients between them all are going to be the same. Right, so there's my value k there, and it's the y coordinate of point C, and that's the one I'm going to try and work out. So I'm going to work out the gradient between 2 of them, but I'm going to try and combine them a bit. You could do this a bit separately and then gather it together at the end. What I'm going to do is I'm going to just keep them together. So let's go for, if they're going to be collinear, I would know that the gradient, so I'll go for the gradient of AC, should equal the gradient of AB. Right, so let's work out the gradient of AC using the y2 minus y1 all over x2 minus x1. We'll just use the gradient formula for that. So A to C. So I'm going to start with k, and I'm going to subtract 2. That's then going to be divided by 5, and I'm going to subtract minus 1. Okay. I'm going to then say that that's going to be equal to, so that gradient and that gradient must be the same if they're collinear. So the gradient of AB will be 6 take away 2, so there's 6 take away 2 because that's the y2 minus y1, and 1 take away minus 1. So 1 take away minus 1, and that's on the bottom. So let me just kind of work out the numbers here. So I've got k minus 2, and then on the bottom I've got 5 minus 1 will give me a 6. Over on this side I've got 4 all over 2. What I'll do then is I'll get rid of the 6 here, and I'll multiply that out over onto this side here, or you can think about it as timesing both sides by 6. So I've got k minus 2 is equal to, and that's going to be 2 times 6. So I've got k minus 2 is equal to 12, and then if I take that minus 2 over to the other side, what I've got is k is equal to 14. So from there what I've done is I've worked out the missing coordinate. That's what I've been asked to do, given that they're collinear. So remember what I'm doing is I'm equating the gradients. So I'm saying that gradient of AC is equal to the gradient of AB. I'm substituting the values in using the equation for the gradient. So just remember that's y2 minus y1 all over x2 minus x1. Okay, and just working through the numbers from there and finding out the unknown part, which is k, and that's collinearity and missing coordinates, sorting them out. Right, so there's 2 other questions here for you. So I'd like you to try these ones. Okay, I've given you the answers. So k is equal to minus 4 for 2, and for question 3, k is equal to minus 3. So show your working, make sure you can work it out and get them, and that might be a wee bit of a twist that you might get for a collinearity question in your exam. Further questions to do on the Maths in Action textbook would be page 5, exercise 2A, question 7, which would be some basic collinearity questions, and page 9, exercise 4, question 8, that will be finding the equation and then showing that the points lie on the line, something similar to collinearity. So good luck on this topic.